Okay. Welcome everyone to the Node Lifecycle Working Group weekly meeting. Today is Monday, the 8th of September 2025. My name is Lucy. I'm one of the working group leads for this working group. As a reminder, although I'm sure none of you have to be reminded, this meeting is subject to the code of conduct. Don't be very silly. It's being recorded as well. So just make sure that you behave yourselves. With that, we have some interesting stuff on the agenda. First, we have Philip and Ryan to talk about declarative node maintenance. So let's jump straight into that. Philip, Ryan, do you want to kick it off?
Yeah, sure. Yeah, we started looking at this topic with Ryan recently. I think maybe I could try to go over the node maintenance like history, like what we did, and then maybe Ryan can take it off from there.
Yeah.
What do you think, Ryan?
Yeah, that sounds good. Go ahead.
Okay, so we share the screen.
Yeah, let me get you co-host so you can share the screen. There you go.
Sorry, I'm here again. So I opened the cap so we can look at the API, what we did a bit. But so yeah, first let's start like why we are doing this and how did we get here. So like basically we like there is like it's hard to go through every issue there, but there is like a bunch of that are plaguing this topic of node maintenance and the node shutdown and also graceful node shutdown, also like eviction, like all sorts of eviction PDBs, etc. And like as we know, like there is a lot of solutions solving this thing, like from like the main ones like the cluster or Carpenter, which basically are looking at how to do the proper node drain, and it has like a bunch of features, and like there's a lot of other like custom solutions for node maintenance and much more. For example, as we saw like from Ryan, like as he did the presentation last time, which NVIDIA uses. And yeah, so like we started like modeling this after like in a simple way, like what we have already in Kubernetes. So we looked at like what's kubectl drain is doing, and also what graceful node shutdown does. So like when you look at the kubectl drain, it's very simple, and it basically cordons the node, so it makes it unschedulable, and basically tries to evict all the pods in the loop until like everything is gone. And this logic is imported by a lot of projects. So they just import kubectl as a library. Yeah, sorry, but yeah, and they basically do not do anything fancy. Like the other solutions that are like that built on top of this like have more like special behavior. So yeah, we are looking at like replacing or not replacing or like supporting most of these solutions to basically allow like outsource this like to Kubernetes or insource this to like basically have like a simple API to basically say I want this node to be drained and all of the pods to be gone. And this is like eviction request comes in. So like currently, like if you have some problems in the cluster or some and you have, for example, setups or there are some PDBs for disruption budgets, then it can happen that like basically the cluster drain is blocked, unless you have like some special toggles like which tells like what PDBs to ignore or after some time to override these PDBs. But this is very finicky and hacky in most of the cases, and it's not something like dependable. Yeah, so like preferably we would like this API to use like the eviction request. And like as we saw before, like the eviction request is like a basic the scheduling feature, and this can be used like if you want to remove all the like workloads from the node. Yeah, so like we started like with the API, which is like pretty simple for now. And yeah, so like one point of contention which we already like discussed a bit is like the node selector. So it adds like a ton of complexity, which we probably do not want or need. So we might like change this API to target only a single node. And yeah, I'm just going through the overview, but and then we will like talk about the implications and other things that depend on this feature and on maintenance. And yeah, so this might be just a single node, and then we have like the couple of stages, which you can see here. So it's basically similar to what we do in kubectl drain. So you have like idle node maintenance, then you cordon the node, and then you drain it, and then you are done. Like this like it's like this is not supposed to be automated. So or I mean like automated by Kubernetes, like changing of the stages. So this is like basically we have like a couple of states and we expect other components to move through these. So either like the autoscaler or some other like higher level component would cycle through these stages. And Ryan also did like his like analysis on this and did this a bit differently. And this is like one of the points we have to solve, like what stages or what states and what transitions like we should support. And like this is it is very hard to design properly because like because it's hard to extend in the future. And like it's hard to it's hard to define a state machine that is like future proof, and it's basically frowned upon on this in Kubernetes to basically define state machines, and that's why we prefer like conditions in statuses since they usually do not depend on each other, and you can just flip them on and off accordingly. I think in our case, this like supports like the node drain or node maintenance story, which is usually the same. And we probably expect like some rules and some like some of these transitions like that. I mean, it's important for like other components to also know like in what's like stage the node is in, and like what stages there will
Have I also lost Philip, or is it just me?
Yeah, like I'm not hearing Philip.
Ryan, do you want to step in and I'll see if I can raise Philip on Slack?
Yeah, sure.
Okay, let me give you screen share power and let me make Philip yeah, here you are. So you have screen share power now, Ryan, in case you want to step in. Yeah, Philip is stuck in a like weird joining state where I can't touch him. But if you want to
Okay.
keep driving, and then whenever Philip manages to get back, he can get back.
Sure.
Oh.
I think. Oh, did we get Philip back?
I don't
Oh
know.
yeah, just tell me if you see him. Otherwise, we'll
yeah
just keep
so
talking.
sorry, can you hear me again?
Oh,
Oh,
there's
welcome
Philip.
back, Philip.
Yeah, so sorry about that. Yeah,
Don't worry, we were about to switch over to Ryan, but if you're okay, we can keep going with you.
Yeah, so yeah, I was talking about the stages, and then we need to properly design them, and
You're
that
not screen sharing anymore.
yeah, let me do that again.
Cool.
Okay. Okay, can you see it?
Yep.
Yeah, so I was talking about the stages, and then we need to like properly design them, and basically together gather all of the use cases that we'll probably like see in this working group in the future, and to think about the solutions, how to make this extensible and but not to overwhelm the users. So this is still work to be done. And then the other thing we did is the drain plan. So this is modeled after the graceful node shutdown. So like as you can see here, like we have this graceful node shutdown feature, which is in beta. It's a kubelet feature, and it's basically like tries to like terminate all of the pods on the node, but it does it in a special way that it does not go like through the like normally when a pod terminates, it's done by deletion. So there is like bunch of issues with graceful node shutdown when we terminate the pod. Like that's for example, the pod is not removed from like a load balancers, or like the connections are still live. And yeah, there is like bunch of problems we have to solve in the graceful node shutdown case. And yeah, and we also have this feature which is called pod priority based graceful node shutdown, and it basically says like which priorities should be shut down, or like which pods should be shut down first or terminated first, and it gives like the time that this should occur in. And this basically overrides, I think, the termination seconds of the pod. So the gracefulness of termination is one thing that we would like to solve. And the other thing is that we do not have like a proper signal what the kubelet is doing. So this is like the kubelet configuration. But when kubelet is executing this, we do not have like a good way, like API-based approach of seeing like what kubelet is doing. And this is like where the declarative node maintenance comes in. So we would like to be able to also look at the graceful node shutdown as like a kind of non-maintenance. And we could use this API to basically signal through the status. Like it could be a controller, or it could be the kubelet itself, that it could signal like what pods are being like terminated, and like what priorities are still to be like done. So this is done like through the drain plan, where we try to model like first we sort like by the pod types and then by priorities. Like this is just yeah, it's also work in progress. It doesn't have to be like this. Also the sorting or ordering can be done in a different way. But we basically try to solve the graceful node shutdown case, where we would also go like according to the pod priorities and have these defaults. So that could be injected on non-maintenance admission. So you would basically first shut down the normal workload pods, then the system critical ones and system node critical ones, and then we would go for the daemon sets. Like the daemon sets themselves are meant for workloads or services that are basically running on each node, and they are usually expected to be running there until the last point of like the node shutdown. Yeah, so that's why we like did the pod type think that it will be like removed after the normal workloads. And so like have like a theoretical use case that's like also we could ask kubelet to terminate static pods. So I say theoretical because like we do not have a good use case for that yet, but it could be done. That's basically it. Yeah, so are there any questions?
When can we have it? Because I could use this now.
So sorry, I didn't hear you.
I was being a little facetious. I said, when can we have this? Because I can use it now.
Yeah. So
Okay,
this
so-
is, yeah, go ahead.
I think. No, go ahead, Philip. I'll come in after.
Yeah, this cap is still like in a very early like phase or stage, and yeah, we would like to first finish the eviction request first. I hope I could like propose the eviction request for 135, and hopefully we'll get somewhere, and then we would like to also like bring in the non-maintenance. But there is like a couple of problems I didn't mention yet, but I will let Lucy speak first.
No, I have comments on Arch, but I think I'll leave them until you've done your presentation and then come back to it, if that's okay.
Yeah,
Because it
sure.
feels better than just coming in the middle of the,
All right, I wanted to wait till Lucy had a chance to talk there, but I do have another question here, or a comment, I guess. When you were looking at you had showed a list, Philip, before of some of the projects that you were studying, and I saw like Cluster Autoscaler and Carpenter and some other things on there. I didn't see it on there, but I just wanted to advise, I think another really big use of this project would be with Cluster API as well, because Cluster API has the ability to do kind of like node upgrades and whatnot, and it uses a drain and cordon as well. And the reason I was kind of facetiously talking about using this now is because we're starting to see interesting patterns of interference between like the cluster API controllers and the cluster autoscaler controllers and like third-party controllers when the user is doing one of these processes where like a node is upgrading, and so an old node is being drained, a new node is being brought in, and like the cluster autoscaler and the cluster API controllers are competing to drain nodes and whatnot. Like I think there's like this has like I just think really wide ranging uses, and I just wanted to mention cluster API.
Yeah, that's actually a good point. Yeah, I remember like we already had like a small short discussion of the cluster API. So yeah, I will bring it to the cap. As I mentioned, like the cap itself is quite stale, so they did not have like a major update in a long time, and we are basically looking at with Ryan at like refreshing the cap, and Ryan would like to take it over to basically add like make it more like feature full and like code, so we can like propose this to like make it alpha feature in a reasonable time frame. So, but yeah, cluster API is for sure a good use case that we would like to add here.
Yeah, and great to hear about the enhancement progress too. Like, yeah, looking forward to seeing it kind of reboot.
Yeah. So the other thing, so like when we like this is like the origin of like creating this cap of basically proposing a better solution for the node drain. And but then like we had like a bunch of conversation with like the architecture folks and other people, and that's also like one of the main points or like main reasons why we started this working group. Is to look at the node lifecycle as a whole. So like as we already see, this API would be integrating with or being integrated by other like components or used, and basically we do not like as of now, like we do not have a good approach of like defining the life cycle of the node. I mean, like the physical machine, which either is like running or operating fully, or only partially, or it is like being drained, or it is being terminated, like with various reasons, either for like a maintenance reason that it will be maybe turned on again, or that it is terminated completely, or it is only restarting for some process to complete, or it is a spot VM that's basically will not be available again. But we like these things are happening in the cluster, but like we do not have any representation like in I mean, like each like cloud provider or each component or actors implement this in various ways, but there is not like a standardized solution that like everybody could see and could basically depend on. Yeah, so like this is like one of the things we have been asked to also look into, and like we yeah, we had discussion with Ryan, and maybe it might be better to split it from the main cap, from the node maintenance one. Yeah, I guess I can let Ryan speak to see what's on his mind.
Sure. Yeah, so Philip and I had some discussion on this. Basically I guess the way I want to open with for this discussion is kind of with an observation to sort of reiterate what's been said in a little bit different way. I think like if you look at what a lot of people do today with node maintenance or various things, like there's a lot of projects out there, and I think that was highlighted with that large long list of projects that are doing various things around the node. And what's interesting is, like, when you look at doing node maintenance, it's sort of like managing like a stateful application in Kubernetes. Like, I almost find it to be very similar. And the solution has been in the ecosystem that when you're managing the lifecycle of a stateful application, right, you're going to write an operator, and you write this operator, you're going to create like a CRD for it, and or maybe not, but you're just going to have it, you're going to have control over a lot of things, like around the object or the pods or different things. And I think what's kind of interesting is, in this case, what we're seeing is sort of like a challenge here, where the operator pattern is I think being done in this case with lifecycle management, but it's sort of creating a new problem for us where we're all trying to lifecycle this node object, and this node object is like this core API. It's not really owned by the operator, and this creates all this entropy, meaning like where if I have my operator for node lifecycle and you have yours, they're not going to really work together, right? You're gonna create labels and annotations on the node, and I'm going to create labels, annotations, and conditions, and whatever else I'm going to do, and then they don't really work together. And so we end up in this place where um, we have our operators. We've been doing they work really well, but they don't really work well with anybody else. And so this idea of like a stateful application and that pattern being applied in the scenario doesn't quite work. And so that's like where which is like something of interest to me. And so what, like, a lot of thinking that I've been doing is like, okay, like what's missing? Like, the pattern's fine, but like how do we like get and take this entropy and really reduce it so that in this case, so that we can give sort of control to the operator so that they can work together and feel like they have some sort of control over the state on the node. So one of the things I've been talking with Philip about is some conditions on the node. The idea would be that we can define some conditions that are going to highlight the node's life cycle to people that are interested. And so today, right, the two conditions on the node is to remind everyone it's ready and not ready. It's very coarse, right? It's not really that useful for the node lifecycle world, right? It's just the kubelets being able to interact with the API server. It's not really doesn't mean a whole lot. I mean, in maintenance scenarios, you could say like, if I were to take a node offline, right, the node could be not ready. That doesn't mean it's undergoing maintenance. It could just mean something else is happening to it, right? So it's not very clear today if you were to use those states or use those conditions as a way to like operate, which is why we see today like people are adding different things around nodes. So I think what's missing is some supported conditions on the node that we can all understand and agree on as like useful things for highlighting the life cycle of the node, and then we can write our controllers around them, and then they can have the ability to work cooperatively together, and also have a way to answer that question of like, what is the kubelet doing right now on this node? Is it draining things? Is it who else is doing work on this node? Like one of the difficult challenges with coordination, right? We don't know what's happening. So that's actually what we've been talking about and what I've been thinking about. And if you want, I can share my screen. I can just show you what this looks like. It's actually pretty straightforward. I think let me take it. Let me see if I got a picture somewhere. I'm sorry, was there a comment? Go ahead.
No, I was just saying you should be able to screen share.
Okay. Let me see if I can. Okay. Let's see, you should see it. Yeah, okay. Yeah, I mean, I was kind of looking at it with this picture here. It's a little small, but I'll zoom in a little bit. Kind of an idea like this. I mean, I don't know if the arrows are exactly correct, but essentially like this idea that maybe we can try and find some conditions on the node that could be more meaningful for us to coordinate our maintenance operations, so we can figure what's going on, and that would sort of lend to when we write this API, this node maintenance API, we can use these conditions to sort of help us understand what's going on on the node. So the two that I have here that I could think of are draining and maintenance. And there might be more, but this is like at least what I could think of. And draining just means that there's a drain in progress. And so I think like the way we could talk about it is like when we start wanting to wire another our other KEP with eviction, is that this would probably mean that there's like some ongoing eviction that's happening, and the kubelet or some other agent is trying to do draining. And so like the node would be in some sort of draining condition. And then maintenance would mean that draining is done, that we have completed our draining operation, and something is going to be taking this node and doing something with it. But whatever it is, it should be in control by some agent, and it's probably going to be impactful to your production workload, so you should probably not be there. So that's what I had in mind for these two conditions, and at least this is, I think, enough to get us started with discussion. Do people have any comments or thoughts about this direction?
So just one, Dominic, come in after. You go now. I'll come after Dominic.
Okay, thank you. So I was the first time joining the group meeting. I'm SIG scheduling TL, and we are working on workload, our scheduling, but probably we are even not at the stage like you are. We still debating on the very basic concept. So I'm not going to talk about that yet. Those things are related, but I just have a comment right about this picture. So I think we may add one more box here. So from maintenance, we probably could go to the provisioning mode, which makes the arrow to making node ready. I'm talking about that because there is also a scenario when a node will be provisioned to the cluster, and scheduler may want to know that the node is going to be ready in some time, and it might already start thinking about start scheduling and so on. So you could think about node provisioning as the same process of provisioning node by cluster autoscaler when a node is going to appear in scheduling, but also as a transition of leaving of the maintenance mode. So the node will eventually be available for scheduling. It will take some time.
Okay, interesting. Does so is this like, maybe we can I'm trying to picture this. So this is like, we've done maintenance, we've validated that like everything we've done is gonna be okay. So we probably start trying to, like, are you bringing? We're not bringing pods back at this point. This is like we're trying to bring up hardware or something. We're attempting to bring the node back, but the kubelet's not there yet.
Right, something like that. That would be the most useful if the node would be capable of accepting new pods to be scheduled in some time, but the node is still not ready to run those pods. It's probably less important in your picture because the scheduling is more a use case in case of autoscaling, when an autoscaler already knows that a node is going to be provisioned. Moreover, autoscaling can already even suggest what kind of pods will be running on this node. So it may already like reserve a space on this node for a pod that it has in mind. So in this context, this is maybe less a scenario for bringing back node from maintenance, but it's also possible.
Okay, I think maybe I understand this as like future capacity expectations, like we want to understand like what the capacity is going to be in the very near future, and so that's useful for various things. Okay, I wrote that down. That's useful for me. I think, and in the context, like I put this, like Philip was talking about the full node life cycle. Definitely, I can understand the argument for this one. So I'll write the use cases down. This is a good one we can hold on to and continue talking about. Thanks, Dominic. Okay, who is next with the hands? Is it Lucy, or you put your hand down? I think
may have been me. Yes. So on the draining stage in this diagram, do you consider this like a binary thing of either every workload on the node is draining or no workloads are? Is that how like you're theorizing it right now?
Yeah. I think yeah, I think when, like, if you're gonna be, I think that's the idea. Like, because I don't, I think what's hard about this is like you could have, for example, you could drain a workload on a node, but the node might not be draining, right? Like it could be you just, need to do something with your application, which I consider different than, I guess, this node is planning to go into some sort of maintenance, and so everything needs to go. Like, maybe put it this way: draining, the idea here is that we're taking away capacity, right? We're taking capacity, not that we're trying to remove a single pod, which this capacity is going to go away.
I see. The reason I bring this up is I've heard from a few users when we've been thinking about how we improve node maintenance, that one of the things that they consider a challenge is that because a lot of the node maintenance stuff we do right now is very much just drain everything and then move on, and because there is a significant long tail from workloads that are very hard to disrupt. So, for example, databases with local volumes where draining them takes a very long time. What I've heard as an ask before, and to be clear, it's not like a hard thing, as an ask before, is can we keep the more drainable / disruption tolerant workloads, the ones that take 5 minutes to drain, on the host and continue to use its CPU clock cycles and etc. up to and until we actually need to get it out for maintenance. And then we don't have this long tail of effectively, if this is like utilization, like a graph, like of this, because instead the stuff that would be long tail is being drained before everyone else. However, I appreciate that's a pretty complex thing for a pretty marginal gain. But I thought I would just plant it in your head.
Yeah, I think I understand what you're saying. I think so. What's really important, I think, from your perspective here is that there's the user is going to control the drain. I think it's like totally in their hands. Like they define what like draining is, and I think that's sort of another part of this puzzle that's really challenging, and that if a person is going to define drain as like, as you say, like we have databases and we want to keep using this node till the end or whatever, that's fine. I think that's like a fine perspective. And there's even some more complicated parts. And so I answered earlier, like, no, draining means everything must go, but like there's lots of other parts of this you could say where, like, what if you had storage volumes that were attached to this node and you didn't want to drain them, right? So like there's other aspects of this where like how do you define what drained actually is? And it's almost indeterminate. So we will need to find like we will need to be clear on like how we communicate this, but I do think it's like a lot of ways up to the user to describe this, and these states are here for them to describe like what the intent is on the node.
Right, that makes sense. I probably should stop talking so other people can do their things. Go ahead.
I think, like, Philip, you raised your hand in the middle of that. Did you want to respond to what Ryan or Lucy was saying?
Yeah, I have a couple of things, but please go ahead first. You had.
No, go ahead. If you want to continue that discussion, I was going to go back to something Dominic said. So if you want to continue on a thought there,
Yeah,
please.
so
Go ahead.
I see like a bunch of like splitting threads like that it could be well followed from this. Yeah, so first like is like about the interaction with the node maintenance. So like as we see, for example, what Lucy said with like the databases, the other workloads, is like there is a lot of room for customization or like customization of the node maintenance process. But this like goes against like the ease of use of the API. So we basically would like this API to be as simple as possible, so that anybody can like trigger it. For example, the graceful node shutdown or like the cluster autoscaler, and they don't. And we would like not like we would like for them not to handle all this like complexity of draining that node. So that's like what we have to always like consider these like two things which are against each other. But it could be solved in some way. So like in my cap, I have shown like one type of ordering of like the drain ordering of the pods. But this could be like customized, and maybe it might be better to even like introduce some entity in the cluster, like a drain plan, like for like a set of nodes or like according to labels, I don't know. And then like the like cluster administrator would basically set up this drain plan, and then and anyone could like trigger the node maintenance, but they would not have to like handle the complexity.
I mean, that makes sense, but basically, just one comment on that. The only thing I'll say on that is that keeping the API simple, keeping the high level intent, I would almost call it simple, is completely fine as long as users you can control that general flow in detail once the intent has been signaled. But yes, I agree. We can't possibly expect every stakeholder on the planet to integrate with every user's possible weird shenanigans. But that's why we have this intent, and that's why we model it in this standardized way so that users can then plug into that. At least that's my view. But I've been holding up you for a very long time, so go ahead.
Yeah, no worries, Lucy. I think like the point that Dominic was bringing up, I think was really interesting and kind of is also another way to look at this complexity or simplicity of API type issue, because when Dominic started talking about like a provisioning stage in here as well, that immediately started getting me thinking about kind of the boundaries that we're drawing here between like the node portion of this that's running on some instance somewhere, and then when even bringing in the word provisioning, and I don't want to get too much into the naming side of this, starts to imply some sort of infrastructure behind it and whatnot, right? And now you're starting to have these, thoughts about like, okay, provisioning implies that, there's some sort of like, instance being started up, or something is happening, a machine is being turned on, something is being created or whatever. And I think it's cool to allow space for that in here, but I just want to be aware of like the boundaries that we're kind of touching on, right? Because one of the things about keeping it very simple and looking at this just from the node perspective is that we can reduce to something very, very minimal. But then does that leave gaps then for us to allow for something like, okay, does someone need to have extra time between maintenance and not ready so that they can signal, hardware is coming, or the hardware already exists, you're just waiting for the kubelet to start back up. So yeah, like I guess I don't really have a deep point to this aside from just I wanted to highlight the boundary that was becoming apparent to me there, because I think that kind of goes into the notion of the complexity of this feature.
So let me comment on that. So I rather mentioned about that for completeness of the circle, and so there's a the what I call provisioning and draining are two opposite operations, and thinking about those may simply allow us to understand what's going to happen there. One thing about one comment about draining is that what we need to do is to remove the capacity, and we are working currently in workload or scheduling on how to do dry run rescheduling of things just in memory to see what would be the impact of an operation, and that's definitely in scope of this working group, because this if I understand correctly, this is one of the goals to understand what would be the impact of the operation that is going to happen. So this is what we are definitely aware of. I was recently thinking about, because scheduling process is a process of adding something to the cluster, but as part of scheduling, we may need to have suggestion what should disappear from the cluster to make a space for a new workload. And maybe so I was thinking about a concept of putting some annotations on pods that notify the controllers that there is an intention to turn down the pod in the nearest future. So the controller should find a new place for it, make a reservation for alternative space for the pod. But I think the clue here is that we not only can suggest where new pods should land after scheduling, but we also can suggest which pods are going to be turned down. So I know that there is a eviction API. I'm maybe it's covered. I'm not looking for alignment at the moment. So maybe I'm talking about things that you designed or suggested already. But this sort of annotations could be also part of the plan that I heard, that the plan is to turn down those nodes, so then we can annotate those pods in the cluster, maybe through scheduler, because we somehow need to have also some sort of coordination. But this is how it may work.
Yeah.
And this provisioning is a opposite process.
Right. I think if Philip will allow me to jump back in here quickly. I think Dominic, when you said it like you're speaking of provisioning as kind of like the opposite or the inverse operation of drain. To me, that makes a lot of sense. Like I understand it's almost like in this sense, provisioning is like the process of preparing to load that node back up with the pods that you expect will be there or something. It's not really provisioning the hardware underneath it.
Yeah.
It's provisioning the workloads or whatever. Like to me, that makes a lot more sense in the framework of, okay, maintenance is completed. There were a number of pods that might have gotten drained off this node, or there might be a number of pods that are waiting that are going to be loaded onto this node. And as the node is going from maintenance into ready state, it's in this kind of loading state or whatever, this kind of so-called provisioning state. I think that makes a little more sense to me. Thank you for clarifying that.
Yeah, in particular, some daemons pods need to go back to those nodes. So we already should know that they have to be there. So we can
Right.
even schedule them before the node is physically schedulable.
Right. And we know that when it finishes its maintenance, there will be pods already waiting to be scheduled there. And they're gonna impact whatever scheduling could further happen there. That makes a lot of sense to me. I'll hand it over to Philip. Thank you.
Yeah, just want to follow up on the annotations you have mentioned. Yeah, this is the case that the eviction request would like to solve, to basically give an intent to a pod that it will be removed. And we are also looking at adding like different kinds of eviction requests. So yeah, like the problem with annotations is that it's hard to scale and like basically make it reactive and like enough for like a large amount of pods to work.
Okay, why is it a problem?
No, I mean like we did look at like the different like kinds of entities that basically need to interact with the eviction request. So we have like various like controllers that would like to basically inject their behavior, which could, for example, with like be with the auto scaling or with the controllers, or we could also like the schedule itself could interject in there. And basically, the behavior is more complex for like simple annotations to work. So basically, you have a bunch of like competing resources to actually update these annotations or taking over the life cycle of the pod. So yeah,
Right. So that's why the suggestion is to make it a part of the sort of a part of scheduling process. So the same way that some scheduler will suggest where to put new workloads in a cluster, and scheduler can accept the placement and turn it into some sort of a reservation. In a similar way, we could remove, like notify about intent to remove. So the opposite reservation, which can also go through scheduler, and let's say that only scheduler should be allowed to in fact trigger the rescheduling and bless this removal eviction plan. That it's just an idea at the moment. I'm just saying that I was thinking about that. We have time for having some alignment here. I'm just bringing it up as a rough idea.
Yeah, I think we are getting a bit off the track here, but yeah, this is like a more complicated topic. So like what you are doing with the scheduling and rescheduling. So let's look into that a bit later. I would like to yeah, I would like to go back to the non-maintenance topic. So I think like we like have these two develop a bit different pieces. So one is the non-maintenance, and the second one is, as we have seen now, like defining the states and the or I mean the conditions or some basically node status to basically add a bunch of different state to the node to see like what's happening about the node lifecycle. And I know like there is also a use case for example, the cloud providers to basically allow them to like hook into this node lifecycle. So for example, they have a bunch of signals to from their VMs, like when they will be shutting down. So they would like to basically signal all of that. So we had like a short discussion with Ryan that maybe we would like to create like a second issue, a second cap. Like the second cap would basically focus on the node lifecycle bits, and the node maintenance would focus on the node maintenance. But there would be like cross referencing between these two caps. Yeah, Lucy.
Yeah, I think this is like one of the main points actually I want to bring up is right now, I don't see a good holistic plan of the interaction between eviction requests and node maintenance. And I think this is really important right now, especially if we're looking at if we're looking at these things as complementing each other. I don't think we even really have a user story. We have thoughts in people's heads, but I don't think there's really consensus yet on what that looks like. And I think it's important, especially for node maintenance, that we nail that down before we go too deep in and realize that we have built a system that does not play well holistically at the high level. I've heard similar things from some SIG Arch folks, so I think this is maybe a thing that we should look at a bit sooner.
Yeah, I think I agree. Like, I think we do these things are going to be all tied together. Yeah, I think so. I think like the kind of from this discussion, I mean, at least my takeaway is that I think the general idea is that to get to a point where we can, like, especially with the node maintenance stuff, we need something on the node to help us out. I think that's like something where this would go, and then we're gonna have to tie this in with a larger picture as to like what it looks like. I guess what would be like the recommendation? I mean, maybe that's what I'd also like to understand. Like, what do people think is the best way to do this? Like, how do we tie all these things together? Is this like a bunch of caps and we reference them all? And is that what you're thinking, Lucy?
I think that let's start with at least, I mean, right now we don't even have rough consensus. So I would love for us to at least get rough consensus on Slack, then start iterating on a KEP that maybe gets wider and wider. And then once we have that, then I think we're in a good spot. But like, I wouldn't rush straight into writing a KEP before we've even like, I don't think we've had enough even discussion. And I think that while we may think we're aligned, I do think there are actually some nuances in our opinions on what the actual integration picture looks like.
Yeah, Michael.
Yeah, I mean, and to Lucy's point too, there was like I think on the agenda for the future, there's like a demo of some of like eviction request implementation at Uber and everything, or maybe that happened already, but like that, I think that would be useful information to see before we get into like writing a cap and whatnot, to the consensus period and everything, right?
So for context, I added that today. Duck, who's somewhere over in that direction, 100 meters that way, has written a full implementation of the eviction request KEP as written because he really wants to use it like right now. And he said he's willing to show that to the group. But it's fully working, fully operational. I have a cluster that has it right now. It just the CRD objects point at uber.com API groups rather than KX ones, but it behaves the exact same way.
Right. So as we're talking about this notion of tying together like node maintenance and like eviction request, if we're even thinking about the idea that these two APIs need to be like, together somehow, I think it would be nice to see like, yeah, some of the prototype work that's going on too will definitely help in our forming our opinion, right?
Yeah, that's certainly very useful, and yeah, we will refer it in the cap and to show like what this will bring.
Yeah. Okay. So shall we start maybe a thread on Slack to discuss some initial opinions on the holistic plan of bringing these two things together, just to get some rough ideas on the table and actually start communicating about it, and then go from there on that. And then next meeting, I believe we don't have we do have a presentation from John Philippe on Cured. Cool. All right. Anything else anyone wants to bring up before we call it? Because you have less than 1 minute, so be speedy.
Yeah, so like this like conversation is a good follow-up, and we can also start refreshing the cap and maybe even continue conversations in the cap. But it can get a bit it can get lost in the cap. So yeah, it's maybe better to start with the Slack first. And yeah, we can revisit it after, like we have 2 presentations, I think, following in the addition of two meetings. So like we can follow up on that later.
Yeah, sounds good. I just started the thread in WG Node Lifecycle if anyone wants to jump in. I won't have time because I'm going straight to another meeting, but so feel free to start that thread for me. Okay, anything else from anyone before we call it? I'll take silence as consent. Thank you all for coming. I'm going to kick off the recording and kick you all out the room. Have a good one.
Thanks.